think it's fair to say when it comes to batteries, we hear various incidents. I think most recently London data center experienced a lead acid battery fire. Does that incident and any others, signal to you anything particular about the current status of backup power infrastructure in the data center industry?
So I think like fires have always been uh, a risk when using any kind of battery backup, right? So it's cost of doing business. We're seeing a rise in the number of battery-related fires simply due to the growing number of data centers being built. So the more compute you put in, the more backup you're going to have, the more batteries that are out there. And if you're using legacy technologies that are inherently prone to fire and exhausting gas, then you're going to have more fires. It's going to be more visible. So I think that's more the current state of the industry is that we're using more of them, right? And so you're going to see more.
Yeah. And just in terms of sort of, I suppose, legacy lead acid, lead acid batteries are still pretty much used by majority of UPS systems, I think, although obviously lithium ion becoming more popular. Are there any particular sort of safety or reliability limitations for that kind of legacy technology?
Yeah, I think the lead acid batteries served a purpose for years, right? But um, they can vent gas like hydrogen when they fail, right? And that poses significant explosion risk and fire risk within the facility. So um, they also run the risk of leaking electrolyte, which can be toxic and cause serious safety hazards and environmental contamination. Uh, they also, in general, they have a higher maintenance requirement than newer chemistries, and that makes them less reliable and really kind of maybe less attractive for people to put into their data centers as you're putting more battery backup units in. If you're going to be using lead acid, then you're going to be, having to up your maintenance requirements if you choose that technology.
Yeah, and I guess whether as a direct result of safety concerns or wider sort of issues to do the data center, energy efficiency, etc., there are various alternative battery technologies that are being looked at by data center operators and being offered by folks like yourself. Um, can you give us some sort of overview of what those newer technologies coming into play?
Yeah, so I think there's quite a few coming into play. So I think lithium ion's been making a play for a while now, right? To get into the data center space, and rightfully so. There's higher energy, right? They've scaled, so their cost has come down significantly. But the standard lithium ion, like LFP, lithium iron phosphate, they don't have the power requirements, I don't believe, to really uh, be useful in this kind of application. Um, you look at some of the newer ones, well, it's not that new, but LTO. So great power density, but expensive and, has some voltage issues. Nickel zinc, it's a new kind of chemistry in this area, and it's great chemistry, aqueous chemistry, higher power ratings as well, but also not as high energy. So you're taking up more space to put that in, and you're getting very low cycle counts and some reliability issues. So uh, I think it's kind of maybe the Wild West, as some might say in this industry right now, because the requirements are changing so quickly. But they're all kind of vying for their position in this market.
So I guess the key considerations, I mean, we've talked about safety, but equally important, if not more, you've got energy density, life cycle performance, maintenance requirements, and sort of total cost of ownership. So bearing in mind those considerations, is there a sort of leading new technology, or as you say, Wild West, of people still working out, what may or may not be the best solution?
Yeah, well, I think um, all the new technologies coming in to replace lead acid, they all have a few things kind of in common. They all are basically less maintenance for sure, right? Because they're sealed systems, like unlike lead acid, which sometimes they're not. Um, they generally have higher C rates, so higher they can deliver more power for a given space. So they're all going to beat the incumbent lead acid with that, but they all have their own kind of downfalls as well. So I think uh, to pick a winner right now, obviously I have a chemistry which I think is going to be a winner. So I think there's some great options out there right now. But what we're working on at LiNova, I think is going to really take over this market here in the coming years.
Okay, I'll ask you a little bit more about that in a minute, but just before we do, everyone knows data centers expanding massively with AI and I guess even ongoing cloud demand. Is there any particular things you're hearing from operators when it comes to balancing that sort of rapid expansion with their sort of wanting resilience and again, sort of safety in the background there in terms of UPS and battery systems?
Yeah. So uh, today operators want more power. Like power density required per server is growing exponentially. And these are to support these dense GPU clusters, right? Uh, and to back that up with like battery backup units, you can't just cram more batteries into that space. So if you're growing exponentially on your energy needs there or your requirements within those data centers, you can't just put more lead acid in there. They just take up too much space, weight, the power, and they don't deliver the power you need. So really, the technology that delivers the most power per unit of space, so the highest power density, is going to win. And we're hearing that across the board. Now, performance is the number one metric that everybody wants. And second, I do believe is safety, right? Like they can't risk uh, a battery fire in their data centers. So power, safety.
Yeah, and I guess therefore operators are potentially rethinking various uh what should we say various considerations when it comes to next gen UPS environments. I mean, thermal management, system design, battery safety. Are you aware of people looking for those improvements or different approaches to those kind of attributes when it comes to assessing, I say newer UPS environments?
So I don't know for sure. So I mentioned earlier, like they've always had to live with a certain amount of that risk, but as you put more of these out into operation, there, it's going to become more frequent, these fires, right? And people are relying on these data centers for more all the time. So they don't have the luxury of downtime, right? So some of these guys are saying 99.999, like four significant figures of reliability that it's got to be up and running. So fire is not an option. Uh, they're looking for ways to engineer fire out of the system, which is, like fire suppression systems and electrolyte sniffing systems to see when a battery might be going into thermal runaway. So that adds cost and complexity to the overall plant. But if the battery is worth it, then they can justify that. So definitely they're looking at all options when it comes to getting rid of these issues around fires in data centers.
Okay, and so it'd be good to understand in terms of your battery technology, how you've positioned it in terms of addressing performance challenges associated with the traditional UPS battery systems and the safety consideration. I suppose, yeah, in a nutshell, what makes your approach fundamentally different?
So we're solving the power density issue that the operators are having at the chemistry level. So um, our battery it's a high power polymer cathode. That's at the core of our technology. It delivers more power per unit volume than anything else really available. So just an example here, maybe our data center cell being built is being built to deliver 10C continuous at a 20C pulse like that, and that's a 2-minute pulse. Uh, we do that while still providing extremely high volumetric energy density and still maintaining that extremely high level of safety. So our cathodes themselves, and this is it's kind of funny, we didn't design this from the beginning, but they don't evolve oxygen when they overheat. So even if the cell was to be heated up or a fire erupted within the data center, it's not going to evolve oxygen when it decomposes. So there's zero chance of thermal runaway with our cell. So there's no gases being evolved. There's nothing to start on fire. Our electrolyte is non-flammable. So effectively, we have a safe cell, and it's inherently safe because chemistry itself is safe.
Okay, and I guess importantly, for operators who've already got UPS infrastructure, is it feasible to integrate new battery technologies like LiNova's into current deployments? Are there any particular barriers, or is it just all upsides? They can swap in and out as required.
Yeah, so yeah, for us, there's really no barriers, right? Our technology, we can build cells to any size, so we can fit them into any size module that the operators are currently using. So, for example, right now we're building a battery backup unit kind of prototype for a certain like a data center application. They just give us the power requirements and the box size, right? And we can fit our cells into that box to deliver more power in less space with a safe cell. So I don't think uh, we necessarily have uh, any barriers.
And in terms of where you are on the journey, I mean, are you already working with UPS folks, data center operators, and just give us some flavor of sort of where you're at in terms of the company's roadmap?
Yeah, so we are fairly new in this space. We set out to commercialize, these like the redox active polymer cathode batteries. So we set out to address the most costly component of the battery, and that is the cathode itself. Um, Along the way, we've discovered that this, conductive polymer cathode is very efficient at delivering power. So the our ability to deliver power uh, is greater than any other battery really available. So this has lent itself very well to the data center market. And so we're just starting down this kind of road, engaging with the operators, engaging with system integrators to get these batteries, built and tested here relatively quickly so that we can, get these into the market.
And I also wonder, I mean, if it's a stupid question, apologies, but I know AI, the workload, certainly in these large language models, that people call them, well, spiky. I was told at an event the other day, I can't call them spiky, but, bursts, from milliseconds from sort of zero to massive. Does that have any impact on the UPS and the batteries? I mean, is that a particular challenge, or is that just, another thing that they can cope with easily enough?
100%. This comes back to the power issue, right? So because they have these spikes, they have to be able to, the battery backup units have to uh, take care of those spikes, right? So if the power goes out, the BBU steps in before the generators do. Those batteries have to be able to handle those spikes in power. And traditional, like that's where lead acid just isn't going to cut it for sure. So they're looking at other chemistries such as LTO, nickel, zinc, and they're able to deliver partially on that. But I believe a chemistry like ours, LiNova's redox active polymer cathode batteries, will deliver the power requirements more than they need right now.
And I think it's no exaggeration to say the data center industry is certainly up to now been fairly traditional. So, if something works or they've been using it for a long time,
Yeah.
they may be reluctant to move somewhere else. Are you finding any of that when you're talking, explaining your new technology, or anyone just saying, well, we're quite happy with what we've already got, or because of this, AI explosion and that's encouraging new thinking that people are more open to what it is that you're doing?
I think, even 2 years ago, we wouldn't have, no, nobody would have picked up the phone. And I called because they didn't need it. And I get it. If it's not fixed, why, or if it's not broke, why fix it? And so, and I'm like that as well, right? But it's broke, right? The current technology being used doesn't work anymore, and there's a tipping point, and really, we've gotten to a point where the amount of compute power being put into these data centers is growing, like I said before, exponentially, and batteries delivering 1C of power just don't cut it anymore. So we we're definitely seeing more people are receptive to new technologies and because their applications require something different, something new.
Yeah, and maybe just picking up on that in terms of what you foresee over the next few years when it comes to UPS and battery technology for the data center? You mentioned you were kind of already at a tipping point. Um, will there come a time when sort of lead acid is a fond memory and that's all? Or just your thoughts, I suppose, as to how quickly the industry might pivot to these newer battery technologies.
I think definitely the ones putting the GPUs in and the ones doing all this new LLM and AI, the backup requirements for those will require the power. And so all these newer chemistries, chemistries like mine will be deployed in those data centers for sure. There's definitely room for, lead acid isn't going away. It's a good chemistry. It's been around for years. It's established. They can recycle it. I do believe the market is growing at a significant pace, and there's room for all technologies. There's going to be a few that maybe take the lion's share of the work, and I believe those will be the ones who can supply the most power, for the least amount of real estate, and to do that in a safe and economical way.
And so just maybe finally your roadmap, you've obviously got the technology. Do you have sort of further iterations, further things that you're looking at developing, or is it pretty much you've got your solution now? It's just a question of delivering it to the market. Just anything you can share as to any future plans.
Yeah, so like we have a solution we're going to deliver to the market. So we've got something we're running with. Are we continue to innovate and improve for sure, right? That's at the core of our business, and uh, I think over time we'll be able to, give better kind of performance to our customers utilizing the same kind of foundational technology around that cathode material. LiNova is a North American-based company. We can source our materials, anywhere in the world. Like we can build our batteries all in North America. We can build them all in Europe, and we can source those cathode materials, anode materials, domestically. So kind of we eliminate these, reliance on foreign supply chains and such as we go forward. So I think we have a huge advantage there over some of the incumbents, which can't do that. Lead acid, obviously, is a great domestic manufactured technology, but they just can't keep up with the performance requirements today. So LiNova intends to, take over for that.
Well, that's great. I mean, it's been lovely to chat, and thanks so much for sharing so many great insights into what's going on in the UPS and battery sort of world as it relates to data centers, and be exciting to watch LiNova as you grow your presence in the market. But Mike, appreciate your time. Thank you.
Okay, I appreciate your time.